Let's look at a simple example of an LED lighting system that might be used for something like recessed lighting or down lighting. And in this case, we can see there are 4 components to our system. We have a printed circuit board with 2 LEDs mounted on the board. And we'll zoom in and look just a little bit at the LEDs. We can see also a TIR lens with 6 elements around the center. This would be a molded plastic element. And as a separate component, we've created a pillow lens with concave lenses on the front. And in the back, we've simply created a case to contain the entire system. And we'll now collapse the system. We can see that all our elements are contained within the case. And as we rotate around and zoom in, we can see that our LEDs are aligned to individual TIR lenses. Now we'll hide the case so that we can see our components on the interior. And in this case, we've already performed a set of ray traces for this example, and we will look at our final ray trace. And in this case, we only plotted a few rays so that we could see both the optical components themselves as well as the ray set. And we'll also change the transparency of our TIR lens so that again we can see the rays reflected out of the TIR lens as well as rays that actually pass through the TIR lens out the side. Now in this case we'll switch back to the first ray trace that we performed. And the first analysis that we did was to look at the far field intensity for our entire lamp system. And we can show a spots diagram in direction cosine space. And we can see that for our 2 LEDs, marked here in blue and red, that we have much of the energy directed along the axis of the system, but we also have a number of rays, and most of these rays would be captured inside the case that are perpendicular to the axis of the system. And we can see the effects of the faceting of the TIR lenses themselves on the resulting far field diagram. Now we can also convert this to a 2D picture in which again we see that the bulk of the energy is directed along the axis of the system. We've also created a contour plot which we can now spin around in 3D and get a sense in angle space of the actual far field intensity of the system. Now as we switch back to our model view, we haven't observed it yet, but we actually had a detector that was placed in the system during the ray trace, and we'll now show that detector plane. And we can now perform an irradiance analysis at the front surface of our detector. In this case, again, we've created a spots diagram with our 2 LEDs marked in red and blue. And we can see from an irradiance standpoint that the bulk of our energy is contained within a square pattern at the detector surface. That's shown more clearly in a 2D plot of the irradiance. And again, we can see the cross-section views passing through the center. And finally, in a contour plot, we can see very clearly that most of our energy is contained in a square pattern at the detector. And we've got a small amount of energy which is slightly canted to one side due to the positioning of the LEDs relative to the pillow lens surface on the front of our lamp system. So this was just a quick look at an example of an LED lighting system using a TIR lens array with a pillow lens on the front surface. And we can see some of the fast analysis features that are available to us within the Apex environment.